Hi and welcome, Pure Maths students. Sorry I'm not able to be with you today, but I thought I would do a video instead rather than passing on my cold to you. So, implicit differentiation, I expect you to have a read of the introductory material to the exercise, have a look particularly at the examples, and then you can watch this video, and then have a go at the questions in the exercise yourself. I've just chosen a selection here. I haven't covered the differentiation of the inverse tan. I expect you to have a look at the box there that describes that and do that on your own. Okay, so let's have a look at this first one here. When you've got implicit differentiation, you've got y's and x's all mixed up and you can't separate them very easily. So what you do is this: you differentiate everything with respect to x. So my first value is going to become x squared becomes 2x, and then I'm going to differentiate 2y with respect to x, so that's d dx 2y. I'll do the same with my y squared, and when I differentiate 5 with respect to x, that's going to drop out. Now, as you can see, it's a bit hard to differentiate these with respect to x when they don't have an x in them. So the way we get around this is we write 2x plus 2y dy times dy dx. Now if you look at that, those dy's will cancel out and you'll get ddx, but I can first of all differentiate it with respect to dy. So I'll show you what that will do in the next line. Do the same with this term here. That dot will just represent x time, sorry. Okay, so now in the next line, what we can do is get those y's to drop out. So it'll be 2x, and if I differentiate 2y with respect to y, that's just simply going to become 2, but I'll still have this dy dx here, you see. Then the y squared will become minus 2y dy dx. So I hope you can see that I'm differentiating this, and this is going to drop out because I've applied that, but I'm still left with this here. Okay, excuse me, equals 0. Next, I'm going to factorize dy dx into 2 minus 2y equals 0, and then I would just rearrange this to get dy dx as my subject, and that's going to be negative 2x all over 2 minus 2y, or we might even change it to 2x over 2y minus 2 is another way of writing that. I'm sure you're okay with that simple rearrangement at the end there. So that is a nice, simple sort of one. And unfortunately, as you can imagine, they are not all like that. Let's see. I've just had a quick check of the answer book. Of course, they've factorized the 2 out of there, so we would have x equals x over y minus 1, and that would be the answer that you have there, which I'm okay with. That's fine. Okay, let's take a look at this one here. X ln y equals 1 plus x. Okay, now I hope you've noticed, and I'm sure you have, that we have to use the product rule here. So we've got x ln y, and to all of that we're going to apply d dx equals, and then when we apply d dx to 1, that's 0, and then when we apply it to x, that's 1. So the right hand side is fairly easy in this case. Now, let's have a look at this left-hand side. Remember our product rule is u dv dx plus v du dx. Okay, so in this case, u is our x, so, and then we're going to be applying our d dx to ln y, plus v, which is ln y, and then we're going to be applying our d dx to x, right? So that's my next line. Now, obviously I can't apply d dx to ln y, so it's going to be d dy ln y dy dx plus, and then this part's easy, isn't it, really, because I can apply d dx to x, that's just 1, so I'm left with ln y there. And then I can just have on this side a 1. Now let's look at this nasty looking thing here. Well, when we differentiate ln y, we get 1 over y, so it's going to be x times 1 over y, and then dy dx plus ln y equals 1. At this point I'm going to do some rearrangement. I'm going to go this first bit we could go x over y dy dx equals 1 minus ln y. And then the next line I'll get dy dx by itself. Dy dx equals, and I'm going to go y into 1 minus ln y all over x. Now let's just have a quick check of the answer book and see if that's what we should be getting or not. What are we on? We're on G. Yeah, no, that's totally what we should be getting. Okay, so don't forget to apply the product rule to the ones that require that. So let's get rid of this out of the way. Okay, so this next one looks like we need to apply the product rule as well. Just down here. Okay. So my next line for r is going to be sine y, and then I'm going to apply d dx to this. This one here is going to be needing the product rule. d dx 2y. We're going to have to do a bit of magic with that. And then cosine x, when I differentiate that with respect to x, it should be minus sine x. Now my next line, this sine y, I'm going to differentiate with respect to y and multiply it by dy dx. I'm just going to leave this more complex bit till later because it's more complex. I'll just get these easier parts out of the way. I'm going to differentiate that with respect to y times dy dx minus sine x. Okay, so my third line, I'm going to have, that should have been sine y up there. I'm going to have cosine y times dy dx. And I'm still leaving this middle bit here, which I need to use the product rule on for a bit later. And then over here, 2y, when I differentiate that with respect to y, it's 2. And I've still got this dy dx here. Okay, now we're ready to deal with this bit here, which is going to require the product rule. Okay, so I'll just pop this here, cosine y dy dx plus. Now, it's going to be x squared, and then I'm going to apply d dx to my y cubed. That's about. Plus, then I'm going to have my v, y cubed, and then I'm going to apply d dx to my x squared. And then I've got this bit here, which I've already completed. Now, Next line, cosine y dy dx, whoops, does not equal, plus, now, the x squared, and I'm going to apply d dy to y cubed. Now remember, why I do this bit here is because d dy multiplied by dy dx leaves me with d dx, which is what I'm meant to be doing, but it allows me to differentiate that y cubed bit. Okay, now the next one is easier because I can straight away differentiate that x squared, which becomes 2x, so I'm just going to go 2x, that's a bit messy, isn't it? I'll go 2x, and then I've got that y cubed there, equals 2 dy dx minus sine x. Okay, so next line here, we're going to go cosine y dy dx plus x squared. Now I can differentiate with respect to y, so it's going to become 3y squared. So I'm just going to put the 3 at the front there, and then the y after the x squared. So I'm going to get that dy dx plus 2xy cubed equals 2 dy dx minus sine x. Now at this point we want to get all of our dy dx's across to one side. So I'm thinking we'll bring it all over to this side here, and then we're going to factorize. So it's going to be dy dx into cosine y plus 3x squared y squared minus 2. And I've pulled everything across to the other side. So I'm going to have minus sine x minus 2xy cubed. Now, if you need to, pause the video at that point and see what I've done. I think I've done it correctly. I've just pulled all of the dy dx terms across, factorized them out, pulled all the other terms across to the other side. Then it should be as simple as minus sine x minus 2xy cubed all over cosine y plus 3x squared y squared minus 2. Let me have a look at the answer book. What number is this? It's R. Looks like they've got a slightly different answer here. Oh, no, it's exactly the same. They've just times everything top and bottom by minus 1. Yeah, so that's exactly the same. Excuse me. Okay, last one I'm going to do is number 3. So we'll get a bit of fresh paper here. Okay, got to find the equation of the tangent to the curve. Now, obviously, in that case, we need to find the gradient function. So I'm going to, and you see here that I can't just do a straight gradient because I've got this y here and here, and it's going to be difficult to separate the y's and x's. So I'm going to differentiate everything with respect to x first, like so. And I hope you've already noticed that we're going to need to use the product rule on the right hand side. Next line, easy peasy, 3x squared plus, now this y cubed term, we're going to go y cubed, and we're going to differentiate with respect to y, but then times it by dy dx. And then over here, we're going to use product rule. So I'm going to go like this, put a bracket in here. We're going to have u, and then we're going to differentiate with respect to x, y, plus v, which is y, and then we're going to differentiate with respect to x for x. Okay, next line, 3x squared plus 3y squared dy dx equals 2, big bracket, and then it's going to be x d dy y times dy dx plus y, because when we differentiate that x, it just becomes 1. My next line is going to be 3x squared plus 3y squared dy dx equals 2 bracket x dy dx plus y. Now we're going to expand everything in the next line, so we get this 2x dy dx plus 2y. Now I'm going to gather all of my dy dx terms together and all my other terms together. So the way I'm going to do it is I'm going to have bring the dy dx's to the left hand side and then factorize. So I'm going to get 3y squared minus 2x. Then I'm going to bring everything else to the other side, so it'll be 2y minus 3x squared. Last line, dy dx is equal to 2y minus 3x squared all over 3y squared minus 2x. Now, I need to find the equation of the tangent at this point. So, at x equals 1, y equals 1, gradient equals. And then we just put in our x and y values into here. So it's going to be 2 minus 3, so it's going to be minus 1. And then on the bottom, 3 times 1 squared, 3 minus 2, which is 1. So it's going to be minus 1. Therefore, our line is going to be y minus y1 equals m into x minus x1. And in this case, we've got these beautiful values here. So y minus 1 equals minus 1 into x minus 1. And we get y equals minus x plus 1 plus 1. And then, so it should be plus 2, I think, should be our value there. Yep. Okay, and that would be how I would do that one. Well, I hope this gives you a bit of a starter on this exercise, guys. And I'll be with you hopefully on Thursday, and we can discuss any problems that you might have. All right, good luck, team. Bye.